The modern Formula One car is an astonishing machine. Made from hundreds of thousands of parts, including advanced electronics, lightweight alloys, and powerful hybrid engines, they must be able to withstand some of the highest G-forces known to man, while being incredibly agile at high speed. But have you ever wondered how an F1 car is made? From its foundation in carbon fiber to the high-tech engine that powers it, let's take a look at what goes into building one of these incredible machines. F1 teams can choose to design and build their own chassis, but they must comply with the rules and regulations set forth by the FIA, the sport's governing body. In terms of power, however, all teams rely on engine manufacturers to supply them with the necessary equipment to compete. Mercedes, Honda, and Ferrari are just a few of the companies that make engines for F1 teams. In recent years, F1 cars have become more like airplanes with wings and diffusers all over them to help generate downforce, which keeps the car planted to the track even at high speeds. And to make sure the airflow is perfectly optimized, teams use two main tools: CFD, or computational fluid dynamics, and wind tunnel testing. Using advanced computer software, engineers can simulate how air will flow around a car at different speeds, which allows them to make adjustments and improvements without having to spend time and money on physical prototypes. Once a design is finalized, it's time to move on to wind tunnel testing, where a scale model of the car is placed in a wind tunnel and spun around at high speeds to see how the air flows around it. This process allows engineers to fine-tune the design of the car and make any necessary adjustments. To create the ultimate aerodynamic package, there are three main components that go into this process. The first is the carbon fiber monocoque, which is the central structure of the car that surrounds the driver and protects them in the event of a crash. It's made from carbon fiber, a lightweight and ultra-strong material that helps to keep the overall weight of the car down. The second component is the wings, which are designed to create downforce, pushing the car down onto the track for better grip. The front wing is typically larger than the rear wing and is mounted on the nose of the car. It generates downforce by forcing the air to move faster over the top surface than the bottom surface, creating a low-pressure area above and a high-pressure area below. The difference in pressure creates a downward pulling force that helps to keep the car stable and improves its handling. The third component is the diffuser, which is located at the rear of the car. It has a curved piece of the car's underbody that helps to accelerate the air flowing underneath the car, reducing the air pressure below the car and increasing downforce. The wings and diffusers work together to create a balanced downforce, which helps the car to take corners faster and reduces the need for braking. Let's talk about the power unit, otherwise known as the engine. Now, F1 engines are actually more like hybrid systems. They combine the power of an internal combustion engine with the energy recovery and efficiency of electric motors and batteries. Let's break it down. First up, we've got the internal combustion engine, also known as the ICE. It's a 1.6-liter V6 turbocharged engine that sits in the middle of the car and provides the majority of the power. Next, there's the motor generator unit kinetic, also known as the MGUK. This is an electric motor that's connected to the wheels and it recovers energy under braking. When the car slows down, the MGUK captures that kinetic energy and stores it in a battery for later use. Then we have the motor generator unit heat, also known as the MGUH. This is another electric motor, but it's connected to the exhaust system and it recovers heat energy from the exhaust gases. Finally, there's the ERS, or Energy Recovery System. It's basically a fancy battery that stores the extra power generated by the MGUK and MGUH and deploys it when needed. So now we know how an F1 car moves through the air and how it gets its power. Let's move on to the transmission and gearbox. The transmission is an 8-speed sequential gearbox that allows the driver to shift gears quickly and efficiently. It's lightweight and durable, which is important because every part of the car must be as efficient as possible. And since there's no clutch pedal in an F1 car, the gear changes are semi-automatic. The driver can change gears using paddles behind the steering wheel, and the gearbox will automatically adjust to the appropriate gear. Moving on to the suspension and wheels, pushrod or pull rod suspension is used to keep the tires in contact with the road and provide a smooth ride for the driver. Some cars use a combination of both types of suspension. The pushrod system uses rods that connect the suspension to the frame and push the tires up and down, while the pull rod system uses rods that are attached to the tires and pulled by the frame. To reduce weight and increase strength, many parts of the suspension are made from titanium and carbon fiber. As for the wheels, they're typically made from a magnesium alloy, which is strong but also lightweight. Let's not forget about the electronics and software. Although the FIA standardizes the ECU or engine control unit, it's still a complex piece of equipment that controls everything, from the engine to the hybrid systems to the telemetry that's sent back to the team. Basically, it's like the brain of the car. The ECU works with thousands of sensors that collect data on everything from the car's speed to the temperature of the engine. That data is then sent back to the team in real time so that the engineers can monitor the car's performance and make any necessary adjustments. Now, let's talk about how all these parts are put together. The final step in making an F1 car is assembly. Each car is hand-built by a team of highly skilled engineers and technicians who must work together to create a perfect machine. Once the car is assembled, it's time to test it out on the track. Before hitting the track, the engines are run on a dyno for hundreds of hours to make sure they're working properly. A shakedown is then performed to make sure the whole car is in good working order before finally hitting the track for real. Alright, now we know how an F1 car is made, but what about the future of these amazing machines? Well, in 2026, new engine regulations will be introduced. These changes are aimed at increasing the amount of electric power used in F1 cars and promoting the use of sustainable fuels. While it remains to be seen exactly what form these changes will take, it's clear that the future of F1 cars is headed in a more electric and sustainable direction. Cost caps were introduced in 2021 to help level the playing field and promote sustainability. Teams are now limited to a certain amount of money that they can spend on developing and building their cars. Additionally, F1 has set a goal to become net zero carbon by 2030. This means that they're working to reduce their carbon footprint and invest in renewable energy sources. One way they're doing this is by partnering with companies such as BP, who will provide sustainable aviation fuel for the series. Alright, now let's talk about one of the most popular engines out there, the Mercedes-AMG F1 engine. It's been used by both the Mercedes and McLaren teams and has a split turbocharger that separates the compressor and turbine sections, allowing each component to operate at its ideal speed for better efficiency. It also features precision engineering with extreme tolerances, which allows for tighter control over the engine's performance. And when it comes to thermal efficiency, this engine is one of the best out there with a rating of over 50%. Next up, we've got the Honda RB-PT, otherwise known as the Red Bull Powertrain's engine. This engine is currently used by both the Red Bull and AlphaTauri teams, and it's known for its compact packaging. Unlike other engines, the designers focused on the tight integration of all the power unit's components, which allowed for a more compact design. This was done in part to free up space in the car for other components, such as the suspension and exhaust system. As a result, the engine is considered to be one of the most compact power units on the grid, which helps to improve the car's overall aerodynamics. Another feature of the Honda RA621 is its high RPM performance. The engine is designed to operate at extremely high RPMs, which allows it to produce maximum power output. This is in contrast to other engines that may prioritize torque over horsepower. And although the engine had some reliability issues early on, they were able to upgrade key components and solve the problem. Last but not least, we have the McLaren engine, which is essentially a customer version of the Mercedes engine. Despite being based on the Mercedes engine, McLaren has managed to tweak it to their own specifications. One of the ways they do this is by working closely with Mercedes to integrate the engine with the chassis of their car. This allows them to optimize the placement of the engine within the car, which helps to improve the overall balance and handling. Another way McLaren sets itself apart is by working on cooling solutions for the engine. Compared to other teams, they've opted for a unique approach by integrating the cooling system into the side pods of the car. This allows for a more compact design and helps to improve the car's overall aerodynamics. And that's a wrap on our journey through the world of F1 car manufacturing. We hope you enjoyed learning about the intricate process that goes into making these high-performance machines. If you're a fan of F1, don't forget to stay tuned for more videos. Thanks for watching, and we'll catch you next time.